Our modern world, it absolutely runs on powerful electric motors. But here's the catch. As we're all shifting towards renewables, a lot of our new energy, think solar panels, massive battery banks, it comes in a completely different flavor, direct current, or DC. So the big question is, how do we bridge that gap? How do we get our new DC power sources to talk to our AC motors? Well, in this explainer, we're going to dive into the incredible tech that makes it all happen.
So here's the fundamental problem, right? You've got a steady, stable DC power source, like a battery. It's just a flat line of energy. But the workhorse motors that power everything from factory floors to electric vehicles, they need that constant back and forth push of alternating current, or AC. You can't just plug one into the other. It won't work. You need some kind of power translator.
And this is it. Now, it might just look like a simple black box, but inside this AC motor drive, or inverter, is where all the magic happens. It takes that flat, boring line of DC power and masterfully reshapes it into the powerful, oscillating sine wave of AC electricity that a motor craves. So how on earth does it pull off this amazing trick?
To really get what's going on, we need to peek under the hood at the core technology. We're about to enter the world of what's called the power converter bridge. Okay, so right at the heart of the drive is a circuit called a converter. Its entire job, its whole reason for being, is to take electricity in one form and convert it into another. For what we're talking about here, it's taking in DC and kicking out a very specific, totally controllable form of AC. Now, you can build these things a few different ways, but for the heavy-duty, high-power stuff, the undisputed champion is the full bridge converter. Just think of it as using 4 super-fast electronic switches to direct the flow of electricity with incredible precision. It's like a traffic cop at the world's busiest intersection. But the real genius here isn't just the layout, it's the switches themselves. All right, let's zoom in on the one component that really made all of this possible, the humble electronic switch, now elevated to absolute superstar status. You see, for the longest time, engineers were kind of stuck. On one hand, you could use something called a BJT. It could handle high power beautifully, but man, it was a pain to control. On the other hand, you had the MOSFET, which was super easy to turn on and off, just a simple voltage, but it wasted a lot of power as heat when you pushed it hard. So you had power or you had simplicity, but you couldn't really have both. Until this brilliant piece of engineering came along, the IGBT. That stands for Insulated Gates Bipolar Transistor. The IGBT is a true hybrid, literally the best of both worlds. It gives you the easy on, easy off voltage control of a MOSFET, but with the high power, low loss performance of a BJT. This single component completely revolutionized power electronics. It was a total game changer. So, with our superstar IGBTs in place, we can finally see how that full bridge converter performs its rhythmic dance to create AC power from scratch. Okay, picture this. You've got 4 of our IGBTs arranged in a square, kind of like a diamond, with the motor sitting right there in the middle. The goal is simple. Send current through that motor, first in one direction, and then immediately in the opposite direction, over and over and over again, incredibly fast. So for the first beat of this dance, we turn on 2 diagonal switches. We'll call them Q1 and Q4. Zap! This creates a clean path for the DC current to flow through the motor from left to right. And boom, that gives us the positive half of our AC wave. Then, just as quickly, Q1 and Q4 switch off. And for the next beat, the other diagonal pair, Q2 and Q3, turn on. This completely reverses the path, sending current through the motor from right to left. And just like that, we've created the negative half of the wave. Now, imagine repeating this dance, positive, negative, thousands of times every single second. By doing that, the full bridge converter literally builds a smooth, powerful AC waveform out of nothing but a flat DC input. It's an incredibly elegant and seriously efficient process. So, what's the big takeaway here? This isn't just some clever circuit diagram in a textbook. This technology is the invisible engine that is powering our entire transition to a more electric future. The source material really hits the nail on the head here. It says that one of the biggest applications of power electronics is controlling electric motors. And that makes perfect sense. This ability to precisely shape electricity gives us an unbelievable amount of control over the machines that build and move our entire world. And I mean, the applications are literally everywhere you look. We're talking about the massive traction motors in trains and electric cars, the incredible power needed for those giant mine haulers, the little forklifts zipping around every warehouse, and yeah, even the battery chargers that power up all these devices in the first place. And just how powerful are we talking? Get this, a DC motor drive using this tech can deliver a staggering 400% more than the motor's rated continuous torque for short bursts. That's the kind of raw, instantaneous power you need to get a heavy electric vehicle or a freight train moving from a dead stop. It's just immense. But hey, it's not all about brute force and muscle. The very same principle is absolutely crucial for protecting our most sensitive systems. It is the core technology inside every single uninterruptible power supply, or UPS, that keeps things like data centers and hospitals online when the grid goes down. Just take a look at this diagram of what's called an online UPS. The AC from the wall is constantly being converted to DC to keep the battery charged. At the same time, an inverter, using our full bridge converter, is constantly performing that rhythmic dance to create a perfect, clean AC signal for whatever is plugged in. So if the main power fails, the battery's already right there, and that dance, it never ever misses a beat.
So, from colossal mining trucks to the servers that hold our entire digital lives, this invisible, high-speed dance of power conversion is the unsung hero of our modern age. It's the critical link connecting our DC-powered future to our AC-powered present. Which really only leaves one question. What will it enable us to build next?
Thanks for watching. Please visit the channel for more content and don't forget to subscribe and like if it was helpful. Comment if something is wrong.